Okay. So, couple things. I want to focus today on questions from homework. I'm going to give you guys a few tools to help you, especially with section 1.7. The quiz is currently scheduled for tomorrow. I think to give everybody a little more time, I'm going to make that Wednesday. Does anyone have an issue with that? If I change the quiz to be Wednesday? Does anyone care either way?
I have no issue.
No issues. Okay. All right. So we'll officially make the quiz Wednesday. It gives you a little more time to finish up chapter 1 homework. So before I dive into anything specific, does anyone have questions from homework that will propel us off into some direction? Anybody? If not, I'm just going to kind of dive into.
No, I haven't finished yet, so I'll turn it in.
Okay. You got a little more time now.
Okay.
Yeah, if I remember, I got to go in there and change the due dates for a couple of things if I'm pushing the quiz out till Wednesday. Does anyone have anything specific from homework? Any questions? I think I'm pretty well caught up on grading the newer homework. So hopefully that's true. I'm pretty sure I've managed that somehow. All right, so let's do this. I want to give you guys a couple of tools to use in section 1.7. And these are kind of things that I used. I don't know if anybody, oh my gosh, I really got to clean this desk off. Everything sort of piles up. I love it. Sorry, what was I saying? Oh yeah, I have no idea. I can't remember if I was actually taught this at any time. I really don't think I was. But I want to show you something kind of nifty if nobody has any specific questions. All right. So let me see. Let me turn my speaker up. Now look here. This is section 1.7. This should look very familiar to most of us. Hopefully, number one, it was not that big of a deal. I do want to show you something kind of nifty in case you didn't notice this. If you go back to page, let's see what page it is. Here, page 94. Look at this little dude here. Right? Some of you guys might know this already. Do you understand what this is saying? So for example, can somebody tell me, how would you say this amount? I don't even know if you can see my writing. Hopefully you can.
14 billion cars.
Yeah, this is 10 to the 9th, which is billion, so that'll be 14 billion cars. Let's try something a little bit trickier. What about 3.15 times 10 to the 6th noodles? How many noodles is that?
3,150,000.
Exactly. This is 3,150,000 noodles. I love it. Right? Some good ramen. I think that'll get us through the next apocalypse if I have that many noodles. Okay. Right. Just better not be shrimp flavor. It's got to be. No, I don't like the shrimp flavor. All right. This should help out if you didn't notice this here. This little dude should definitely help on a few situations. You just have to realize what it means when it's 0.15. That means it's the next place over. And if this is 3 million, then this has got to be there's an understood 0 here, right? What am I trying to use my mouse to write? That's not good. I've got a pen right here. There's an understood 0 right here. So this will be 150,000. This is the next place over for million. Is everybody okay with it? Anybody not okay with what just happened? Okay. So hopefully that helps with something like number 1, where they just tell you 148.6 million. Well, you know what million is. So you can immediately, and then you just have to move it over once, twice from there. Okay, maybe. There's a few different ways to do that problem. Okay. You guys stay with me now. So either you haven't done this homework yet, or you did this homework and you got a few or many, maybe many wrong. Okay. So I don't know if you guys have looked at that. Now watch this. Here's where the little kind of trick comes in on number 2. The problem with this section, the math isn't, let me see, how do I say it? Anyway, it's the numbers, right? The numbers get in our way because they're not nice. They're not 50. They're 148.6 million, right? If the numbers were nicer, my brain could tell what to do. This sounds really weird. But so for example, number 2 says, how much money did the government take in? Well, the numbers kind of get in our way and we're like, I have no idea what to do with these. Let me just guess what to do with these. So here's what I suggest. What if there were 50 tax returns filed and each one was $10, right? So on average, each one was $10. So 50 tax returns filed, each one was $10. How much total money would that be? Is this thing on?
500.
Oh. Yeah, right? Is anybody not with me on that? And some of you guys, anybody concerned about where the hell 50 and 10 came from? Why are you allowed to do that, Jeff? Because I'm not really doing the problem yet, right? I'm investigating the problem. So this feels weird maybe to some people. Did I actually just change it? My answer is going to be $500 now. No, that doesn't make any sense because that's not the problem. But I know whatever this number is, I'm going to multiply it by what this number is. Okay, go back to the gross numbers now and do what we just said. Does that make sense to anybody? Some of you guys don't need to do that. Fantastic. You can kind of see what to do no matter how ugly the numbers get. But some of us need to move the ugly numbers out of the way for a minute. Does that appeal to anybody? Does anyone have any opinion on what just happened? No, that's not going to help anybody. I don't know. I'm getting no feedback. All right.
No, it actually helps me a lot. I was having trouble with that, so thank you.
Okay. Does anyone not understand what just happened and want to understand what just happened? Anybody? I don't know how to, I need some kind of feedback.
No, I understood everything.
Oh,
Just going based off of, and I just left it in the calculator and continued to calculate the entire
okay.
amount.
All right. So like I said, some people don't need the little trick I just said, but that little trick is really helpful. I think. Okay. Thank you guys. I'm not, the feedback could be, you made things worse, Jeff. What you just did sucked. That would be fine feedback because I'm supposed to be able to figure out another way to explain things then, right? That's kind of like, why I get paid anything. Okay, I like it. Oh,
You still
chats are
supposed to be putting the answers into exponential form.
scientific notation. Yeah.
There you go, scientific notation.
So it says perform the calculation in scientific notation. Well, from number 1, you've got the numbers already in scientific notation as your answers, right? So then you take those two and you multiply them. How do I know I multiply them? Because I used the little trick by making the numbers nicer. Is that okay? Or is there another level of question now?
No, I got you. Thank you.
Okay. And then the right how your answer would be pronounced, you can go back to that table and see what the various powers mean, right? The trillions and the millions and the billions. That's one way to do it. Or you can write it into decimal notation and then just put the commas in and count over to see if it's going to be 1,000, million, billion, trillion. Okay. All right. Maybe. Are you guys with me? I'm trying to help. I really am. But I need something. Okay. And then when you get to here, so here you're going to have a total amount of money. And then they tell you each bill is this thick. If all of the money in 2 was paid in dollar bills, how many inches high would it be if they put in one stack? So again, you're going to get something gross from number 2. Your answer number 2 is going to be really disgusting, right? It's going to be gross answer. And then this is not very nice. This is gross also. So let me pretend like my answer to number 2 was the $500. And let's pretend that they're each 4 inches thick, right? We're talking some, can you imagine that? If each dollar bill is 4 inches thick, dude. Can somebody tell me how tall the stack would be if I stacked $500 bills and they're each 4 inches thick? How tall would that stack be? What would you do?
2,000.
2,000.
Yeah, you would multiply, right? So take your gross number you got from number 2 for the money, and you take the gross inches they give you right here, and you multiply. So it's all about what operation do I apply to these disgusting numbers? So again, I'm trying to tell you, you are completely allowed to change the numbers as some side work just to know what to do. It's fine. There's nothing wrong with that. It's not against the rules. I'm just exploring the ideas. Okay. Okay. Maybe. I don't know. Hopefully this is helping, because when I graded this, I saw a lot of people were having issues, and mostly it was about what to do, right? What do I do with these damn numbers? All right. And then that same kind of trick will get you through quite a few of these. Okay. I don't know. Is there any other specific questions from this section as we're looking at this section?
Can we try number 5 real quick?
Okay, good. I was about to try to do number 5. So what percentage of the way to the sun would that big old stack of dollar bills reach? So on number 4, you're going to figure out the number of miles that your stack of money is. Everybody with me? So you're going to figure out how tall the stack of, here's your stack of money. Holy shit, Jeff. All right. Pretend like that's a good picture. That's a crap picture. Oh, too bad. I don't care. So here's your money. And you stacked it all up. And from number 4, you're going to know how many miles high it is. And then they tell you how many miles it is to the sun. So somebody give me a number. Give me just a fake number, a nice number. How many miles high is your money stack? So just give me a number. Sorry?
10.
10.
10.
Kick ass. Wait, what's happening? Oh, number 6. Okay, we'll do that next. And then somebody has okay, we'll get to page 85. All right. So let's pretend like the answer is 10 miles. The answer will not be 10 miles, but let's pretend like it's 10. And somebody else give me, now the sun is really far away. Somebody give me a slightly bigger round number for how far away the sun is.
1,000.
1,000. I love it. Kick ass. So let's pretend like the sun is 1,000 miles away. So, life on Earth never evolved, or it's very different. We're all lava creatures. But that's okay. We'll get past that. Sun is 1,000 miles away, and my stack of money is 10 miles high. What percentage is my stack of money compared to the distance to the sun? How do I figure that out? What do I do? So have I made it all the way to the sun with my stack of money?
Divided by.
No.
So I've made it how far? I made it 10 miles out of 1,000. That is how I construct a percentage. So what am I going to do? I'm going to take the actual answer number 4, which is going to be gross. I'm going to divide it by the distance they give me in number 5. That's how I figure out a percentage. Maybe, is that right? So you guys, I really want you to understand the math in this section is easy. The numbers get in the way. We don't know what easy math to do because this is all just multiply or divide or whatever. So it's not like a hard thing to set up, but the thing that's getting in our way is the numbers are gross. So that's why I really, really like this idea. All right. I'll stop pushing it. You can use it or not. It's up to you. Does that help for the person that asked about number 5?
Yes, absolutely. Thank you.
Okay. Is there any other questions on this section? I think there's somebody else asked for number 6. Is that what it was? Let me see. I'm going to clear all this drawing away. Was somebody asking about this one? I think. Let me see. Chat. I think somebody was. Okay.
Yes, please.
Okay. The total amount of money taken in by the federal. Oh my goodness. It's early, Jeff. Are you drunk? I don't know. Total amount of money taken in by the federal government in 2014 was about $3.02 trillion. What percentage came from personal income taxes? Refer back to question 2. So in question 2, you figured out the total amount of income taxes, right? Let's pretend like that was the $500. Remember the $500? And then let's say that the total amount of money, the federal government, let's say that's $3,000. The total amount of money they take in, because they get more than just from personal income taxes, right? They obviously do. How do I figure out what percent of this that this represents? How do I figure out the percentage? We just did it.
Divided?
Yes. I want to know 500 out of 3,000, but you're not going to use 500. You're going to use your answer to question 2. You're not going to use 3,000. You're going to use this number because those numbers represent the ideas that need to go here and here. That's why I can make up whatever number I want to, because no matter what the number is, I still have to do the same math to it. I really want you guys to get this. So if I make the numbers nicer and see what math I do, I use the same math on the ugly numbers because it's an idea. The numbers don't tell me what to do. We're the humans. They do what we want them to do. Dadgummit. All right. Maybe? Is that all right? No? Okay. All right. So let me see. What else did I miss here? I think somebody had a question from page 85. Let's take a look there. I'm sorry, number 1. Oh, all right. All right, guys. All right. All right. Let's say, all right. Because a few people had trouble with this, but it's staring you right in the face. But it's, if I ate a lot of M&Ms, and I kept track of the colors of M&Ms. And I noticed that 30% of the M&Ms that I was getting were brown. What would be the probability that I go into a new bag? What would be the probability I'm going to get a brown one based on my observations?
30%.
30%. Number one says just about 51.5% of the adults in America are women. That's our observation. So we're like 30% of the M&Ms that I've eaten were brown. What's the probability you run into a woman as the next person you run into?
51.5%.
Yeah, they give it to you. Yeah. And again, this problem has issues because we recognize that there are more than these two, or, you know, some of us do, but we'll go with what the problem is saying. All right. I'm not going to bring up that whole topic right now if you can't move into the current century, but we'll just go with what the problem says. Is everybody with that? Do you guys understand? All right, maybe, no? No, all right, I don't know, all right. I don't understand. So if there are 11% of people that are left-handed, the probability that the next person you meet is left-handed would be 11% chance. Because 11% of the people, there's an 11% chance that you run into one of those people. I don't, all right, I gotta think. I don't know how else to say this. That's what probability means. Fundamentally, it is the definition of probability, is how many chances do I have to pick this type of thing, right? So, let me try one more way. Let me try one more way. All right, guys. Let me see if I can find some blank space here. Hold on. All right, here we go. So let's say in a bag, there are 3 blue poker chips and 7 green poker chips. What percent of the chips are blue?
30.
Say again, sorry.
30.
Are you saying 30?
Yeah.
Yes, okay. So 3 out of 10, so 30% of the poker chips are blue. So if I reach my hand into that bag, what is the probability that I get a blue poker chip?
30%.
It's 30%. So now, is that okay?
Yes, just making.
All right, let me go one step further, and then I'll drop this. Blah 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 blah. Let me just clear. What am I doing? All right, let me redraw this. So in this bag, let's say that there's 515 women in this giant bag, okay? And then there's, you can do it, Jeff, 485 men. What's the probability? What's the percentage of women?
Is it 51%?
51.5.
51.5%, because there's 1,000 total, right? So what's the probability that I'll pick a woman?
51.5%.
51.5%. That is exactly what they're saying. They tell you that there's this percentage of people in the bag, except the bag now is America, I guess. I can't remember if it was America. I love somebody. All right, wait a minute. Before I go any further, does that make sense?
Yes. Just to confirm, probability just means percentage. Because for some reason, I think that I kept doing 1 out of or 10 out
Yeah.
of. That it converting into, okay, got it. Okay, thank you.
The basic idea of probability is it's the percentage that matches what you're looking for out of the total things. That's what probability is. Can it get more complicated than that idea? Yes, but it actually always comes back to that idea. Okay, I like it. But I like somebody did say this. You didn't have to say this in the problem, but I like somebody said, well, it depends on my local demographics. And I'm like, oh, that's such a beautiful answer. Oh my God. Because that's for the whole country. But what if I live in an area where there's 9 men for every woman? Then the probability I run into either one next is going to be different from somebody who lives somewhere else. But that's fine. That's a little too deep. But I love that. Can't remember who said that, but I appreciate that. Anything else, guys? We're wide open now. You guys can ask anything. Number 3 from here. Let's see. Yeah, this one gave people trouble. All right. How about number 2 real quick? Let's just do number 2. Let's just all do number 2. Let's get this out of the way. 535 members. How many would you expect to be female? Given this is true. What's happening? So how many?
51.5.
Well, you would expect 51.5% of them to be women if it truly is representative of the United States, right? So if you do that work, 0.515, right? Change that into a decimal times 535. What do you guys get?
.8.
No. Try it again. 275.5. So about 276. All right, let me stop for a minute. You guys with me? So, all right, guys, really get this. That 11% number, real quick, let's step out of this problem for a minute. Now listen, that 11% left-handed is the last estimate I've seen for the percentage of everybody who's left-handed. Who in here is left-handed? Anybody? We're not gonna like find you and do something weird to you, but is anybody left-handed? I'm not trying to, anybody left-handed? Quincy, are you left-handed?
I'm left-handed.
Tristan, okay. Have you ever had trouble going into a classroom and getting a desk that was actually a left-handed desk?
Yeah, that and writing on the whiteboard are my two
Yes, okay.
Achilles heels.
Exactly. So, how do they try to plan? Now, nowadays they've got chairs that are supposedly work for both, no matter what. How do they determine how many left-handed desks to put into a classroom? How do you think they do that?
They take the probability of what a student will be left-handed in their classroom.
So if there were 50 chairs in a classroom, they would take 11% of 50, and then hopefully they would put like 1 or 2 more than that or something. You never know. I really want you to understand. This is how we do this. So when I'm doing this, I'm saying how many would I, if I had 535 people, how many would I expect to be women? It would be 51.5% of them. If it isn't this, if it's not just not this, but is like really far away from this, then I have to stop and think, all right, where am I? Why is that true? Is this a gathering of like an all-male club, right? Or what's going on here? What would make that true? So that's what number 3 is all about. Number 3 says, now actually I looked it up and I think there's 100 23. I can't remember what I looked up. Thankfully, we're going up. But let's just go with the number they give us. There are really 104 women in Congress, and we expected there to be 276. So this question is there's a lot of different answers you can give me about this question, but does that make sense now how number 3 is all about? I'm not going to give you an answer because it depends on your perspective, but and by the way, some people are saying, well, it just means that men are more interested in politics. I'm like, no, I don't know. But anyway, there's a lot of different ways to look at that. Does that help? Is that better? Anybody?
Yeah, that helps. I had to look at the question again because I put it into numerical form or something or another. Okay, thank you.
All right. All right, guys. We're wide open right now. Anything else from homework that just really drove you crazy? Anything else? You could even send me a private message if for some reason you don't want people to know you're asking a question.
I got one. Another one.
Yes.
From 1-7. Can we go to number 7, please?
Yeah, hold on, let me see. What is that? Let's see, how close did I get? Yay. Oh, okay. I think this is one that's worded weird. Let's see, among those earning $10 million or more, the average amount of taxes paid was this. What percentage is that of the government's revenue? So here's the government's revenue right here, right?
Right.
And then they want to know what percentage of this is that. So how do I set up a percentage?
You would write it all out, and then you would divide.
Divide, yes. Divide what by what?
The average amount. Would you divide 7.88 times 10 to the 6th power over 3.02 trillion?
Yes, exactly. You want to know this out of this. Part divided by whole. I love it.
Okay. I got it wrong on my paper. I was using that to clarify.
Wanna
Understood.
bring the answer from a question 2?
Sorry?
Wanna bring the answer from a question 2 and put it divided by 3.02?
Oh, no. That's for number 6.
Yeah, this is 6.
How about number 7?
Ah, okay.
Yeah. Number 6 we already talked about. Number 7 was a new question. Yeah. By the way, real quick, guys, real quick. I got to talk about this since we're talking about taxes. Do you guys understand that when they talk about raising the top tax rate to even if they raise the top tax rate to 70%, for some reason, so many people in this country believe that means that you pay 70% of all the money you make, right? I mean, it's amazing. Do you understand that that would be 70% of the money you make above $5 million or something? Do you follow what I'm saying? So I've seen so many people say, man, if I earn $1 more, I'm going to be in a higher tax bracket. Oh my God. No, you don't pay the higher tax on your whole income. You're going to pay it on that $1 that's above that level. I don't know if you guys are with me at all or not. I really need to find some time to just talk specifically about taxes, because so many people are persuaded by political arguments that assume misconceptions about taxes. And unfortunately, a lot of people have misconceptions about taxes. So then they're easily swayed by these dumbass arguments, right? Anyway, sorry. That's a little side note. Some of you guys are probably relatively new to paying taxes. So welcome. Let me see. Oh, okay. Yeah. Yeah, I'll figure out. I haven't got much put together right now, but it would be nice just to talk about income taxes and how they really work, so that when a politician says something, you're like, well, that's a bunch of shit. Thank you. Good to know that you're full of shit. All right. Let me see. All right. Anything else, guys, before we move on? Anything at all from any other homework stuff? No. Okay. All right. All right. Let's see. So we got up through. Oh, I still have to look at the rest of the personalities. I'm sorry. It's been insane. 1-9, we finished it last time, but it's the one about stem and leaf plots and the histograms and all that kind of business. So I don't know. I think a lot of you guys haven't even had a chance to get in there, which is why if you got to class a little late, I said quiz, which is scheduled for tomorrow, we're going to move it to Wednesday. We're going to move the quiz to Wednesday, give you a little more time to catch up on 1-9 homework. Okay. This shouldn't be too horrible. We'll see if you agree with me or not. All right. So we'll do a little preview of the next section. In fact, I think, yeah, let's see. Let me see if I can find this. Here we go. Perfect. All right, let's try this out. Because I didn't really assign this little prep skills, but it's the prep skills at the beginning of the chapter. Can somebody, all right, you guys take a minute and do this first problem here. Do you guys remember how to do this problem? And hopefully you do, because this has been kind of the theme of the day in a way, is how to calculate a percentage given a part and a whole, right? So what would I do to calculate this percentage?
Oh, sorry.
Oh, 120 divided by 500?
Yes, it's part divided by whole. So 120 divided by 500. And I want to show you, let me see if I can convince some of you guys of a different way to do this, just a slightly different way. All right, somebody's got the answer. Watch what I could do. Now let me just show you this. You don't have to do it this way if you don't want to, but so watch me read this in English and translate to Mathish. 120, okay, 120 is, what is that in Mathish? What is in math? What do you think the word is translates into?
Divide?
No. All right, let me help you out.
Multiply.
5 plus 2 is what?
7.
Equal.
Is
Oh, it means
7
equals.
means equals. Means equals. I love it. So 120 is what percent? I don't know what percent. So what percent of means multiply 500. 120 is what percent of 500?
24.
All right, and I know a lot of people are like, well, I'm not going to do it that way, Jeff. All right, how do I solve for x? I would divide by 500, divide by 500, which is exactly what we're supposed to do. So if you're not put off by equations, and you kind of need not to be, that's another way to kind of do this. But these problems, every single one of these problems is the same idea. So I don't really need the equation to help me here. right? What am I going to do for each of these problems? I'm going to do the same thing I did for part A. I'm going to take this divided by this divided by this divided by, okay, so that's simple enough. What do you
So
guys get
that'd
for,
be,
sorry.
that'd
Go
be 0.24.
Oh yeah, for part A, yes, I like it. But be careful. So what percent then? So you get 0.24. So what percent is that?
Point.
0.24. How do you change it into a percent?
24%.
Point two,
Bam, bam.
2.4.
Nope, you got to move it twice, right?
Yeah.
Because percent is per 100, 2 zeros.
Okay.
Move the decimal twice. I love it. Is everybody with me on that? It's
Yeah.
always two movements. You just got to move it in the right direction. So part B would be 11 out of 20, which I can actually do this times 5 times 5, 55 out of 100. What is that as a percentage? 55 per 100 is, I love you guys. What does percent mean? What does percent mean? It means per 100. That's where the word cent comes from. How many cents in a dollar?
100.
Holy shit. So the word cent is from the Latin centum. We need to know that, no. But percent means per 100. So what's another way to say 55 per 100 is 55%. Bam,
Yeah.
bam. Anyway, sorry. And if you just do 11 divided by 20, don't you get 0.55?
Yep.
Crazy shit. All right, I love it. Anyway, I think we all get the idea. So then I would just do 7,000 divided by 12,500, move the decimal over twice, done. All right. Now how to do, what's the same thing about A and B? What do I have to do first in part A? If I was going to do this by hand, what do I have to do first? Anybody? Part A, what do I have to do first?
Add it
You
all
have
up.
to add all the top parts.
Yeah, I've got to add it up because in this case, the big ass bar breaks it up into the top problem and the bottom problem. Well, the bottom's not a problem. That's nice. The bottom is nice. And if I add up the top, what do I get? I think I get 79. Did I add that right? 20, 47, 58, 79. Yeah. And that does not go in evenly. So that's why it says convert fractions to decimals rounded to the nearest tenth. Can somebody tell me what that would be then?
What's the question again? Sorry.
So take this and convert the fraction to a decimal, rounded to the nearest.
Mom, we're gonna take you.
13.2.
It would be 80, wouldn't it?
And then right after we're done, can we
All right.
for an interview downtown?
Wait, what's happening? Everybody mute yourself if you're not talking to me.
I think so.
All right, I'm gonna do that for you. There we go. All right, the top is definitely 79, right? When you add those together. Is everybody cool with that? I'm getting a lot of chats. Okay, here we go. Okay. Yeah, so you get 13 point, you get 13.166666, is that right? So then you
Yes,
round it to the nearest tenth is 0.2 of it. Check. And of course, part B is really the same idea, except of course, what do you have to do first here?
Figure out the denominator.
Figure out the denominator. That's right. This one comes out nice, I think. Yes. What do you guys get for the denominator? Denominator.
-10.
-10, 11. What's 100 divided by -10?
-10.
-10, crazy. That's an easy one. I don't have to worry about this shit. And then part C, of course, is do the top, do the bottom. Now, here's why, real quick, here's why so many people think that division is last. Why is division last in this problem? Because it's a big ass bar, and we understand that to mean there's a top, there's understood parentheses there, and there's understood parentheses there. But if I see a problem like this, oops, Jeff, 5 minus 4 divided by 2 plus 3, do I do division last in this problem? What's order of operations say? Parentheses, please excuse my dumb ass son. So what comes first?
You would divide.
You would divide first. Of course you would. So the difference between this problem and that problem is there are no parentheses around those two things, but there are understood parentheses around these things. And that's what really sucks about the big ass bar notation is we forget to say that when we first introduce that. Right. I wish that more teachers would say that. Okay. Woo! How you guys doing out there? So apparently, this next section is going to deal with fractions and decimals and percentages. And then somehow number 3 is all about putting things in order. That should be pretty straightforward. All right, let me clear all this away. Let's take a peek at what the next section is going to be about. Let's clear all this away. Bam. So here we're going to talk about, finally. So we're going to talk about a couple of specific things, what to do for math tests. I've actually got some handouts that I'm going to put up on Canvas for tomorrow about taking a math test, what you can do. We're going to analyze how do I say this? The overall effect of a single question. So if you skip a question or should you give it a try or something. And then the real meat of this section is going to be about different ways to measure the center of data, measure the average, right? And you guys already know how to find what we call the average. So what we call the average in everyday life is actually related to a very specific average. It's called the mean. Has anyone ever heard that word before besides, to describe me? Anybody ever heard this word to be used in place of average? It's called the mean. No?
Yeah.
I guess with me.
Yes.
I think everybody.
Yeah.
All right. And there are other averages that exist. They're called the median and the mode. And I might show you one more. We'll see. I might show you one more besides that. So I don't know if anybody's ever heard the median before. Besides in the road, right? The median. Where's the median in the road?
In the middle.
In the middle, crazy. So the median would be the number that's in the middle. Does that kind of make sense? Beautiful, beautiful, beautiful. Okay. And the mode, we'll talk about that. Let me see. Let me clear this away. I kind of planned on more questions, so I didn't really think we'd get into this section. I don't want to talk about this yet. So tomorrow we're going to talk about what to do when you got a test, what you should focus on, and then we'll get into the meat of analyzing data. We're finally going to start to analyze some more data. We did a little bit of that last section. Let me see, where can I go here? Blah, 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 blah. Yeah, blah, 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 blah. So then they give you data, they ask you to find the average and so forth. Now watch, one thing I want to ask you real quick. Just looking at the data, which average do you think will be smaller and why? What kind of sticks out to you between these two exams? What's the big difference between these two exams? A major difference.
The average score is incredibly different.
What do you mean? Oh, right here?
Yeah. It's just like there's a huge discrepancy between like what they got on the first and what they got on the second, I guess.
Sure.
If you
Sure. But there's one specific grade that I'm looking at that should just jump out at you.
that
Creed
Creed,
was cheating on the first one.
Creed,
Yeah.
right? I don't know if it's the same Creed from The Office. I have no idea.
Scott Stapp.
It looks like this was all The Office people. But Creed probably got caught cheating or didn't show up, right? So look at how some of these go up, these go up, this goes up, this goes up. It looks like a lot of people's grades went up. Some of them went down a little bit, most of them went up. But won't that kind of throw this average off?
Yes.
Okay, I like it. And teachers sometimes get too focused on the average. So I don't normally have a situation where I have somebody have a 0, but I do have situations where I'll have like 3 people get 20s. Like my grades will look like 22, 26, 28, and then 63, 67. Do you guys understand what I'm saying? If I put them all in order? So if I calculate the average and it comes out to be 69.7, well, that's because of these 3 grades right there. If I ignore these, I can see what the actual kind of average was because something happened with these people, right? So I'm not going to, so if I did the actual average and it came out to be 76, that's actually pretty good. So I'm not going to yell at my students and say, you guys sucked. Your average was below 70. Good Lord, what happened? Well, I normally wouldn't do that anyway, but I don't know if you guys understand what I'm saying. But it's just one more thing to look for in your data is something called outliers. Have you guys ever heard Outliers? I'm almost certain you have.
Yes.
It's an excellent book, by the way, too, by Malcolm Gladwell, Outliers. But the effect of outliers on an average is huge. So as a teacher, you have to be careful and take a lot more information into account than just the average. All right. Well, if nobody else has any questions, I think that's even further than I planned on getting today. So that's good for me. I'm fine with having an early day if you guys are fine with that. Let me know if you guys have questions. Otherwise, I think we'll wrap up and then be ready tomorrow. Finish up chapter 1 so you bring questions tomorrow to be ready for that quiz the next day.
I have a question, and I know it's
Yes.
basic. It's from 1.6. It's the skills. Number 4. I know it's so basic, but for me, I don't know. Fractions and I just don't get along, or conversion, whatever.
Is this the one with the 1 over a bunch of 10s?
Yeah,
Okay.
I'm like, because I even questioned myself. I had to like put a question mark next to it myself. I'm like,
Let me ask you something.
okay.
How
go
did
ahead.
you do number 2?
Number 2, there's 3 of them, so I just saw the third power, and then I was able
It's a
to
negative third power.
well,
So what is
negative, yeah. Oh, I think I even messed up number 3 by accident. Because I got negative 1,000.
Oh, that's a problem. A negative power does not mean turn the problem negative. Does anyone remember what a negative power means?
Is it so each 10 isn't negative, it's just
Yeah, that would be this down here. If it's up here, it means something
Oh.
different. Yeah. Does anyone remember what this is?
Wouldn't
yeah.
it be like 0.0?
Eventually, yeah, but
Or
I
like
don't.
to the left?
This is
Yeah, but why? We're getting to
one
the,
over
yes.
x to the power 1.
So I really want you to, when there's a negative in front of something, that means negative in terms of addition. So it's like I'd have to add 10 to get back to 0. That's what a negative in front means. I'm down 10 additively. A negative in the exponent means I'm down this multiplicatively. So like a 10 to the negative 1 would mean I'm down 1/10. So this idea of loss, but since it's up in the power, it's multiplicatively. So if I'm losing something multiplicatively, I'm dividing. If I'm losing something additively, I am subtracting. I really want you guys to get this. So a negative power means flip. So if I had 10 to the negative 2, that would be 1 over 2 tens, which would be 1 over 100, which would be 0.01, which is what somebody was talking about. Move the decimal back twice.
Oof. Got it.
Yeah. So now this one is kind of the reverse of this one. So how many tens are on the bottom? So it's gonna be 10 to a negative power. Yeah. Maybe.
Got it.
Okay. All right. How's everybody else? Anything else, guys?
I'm confused on 1.9 question 4.
9?
Yeah,
Let's see where I am. Oops, went too far.
it's like the data frequency distribution.
Oops. Oh, okay. So let me get this one started.
Okay.
So it says your first class should be 10 to 19.9. So then the next class would be 20 to 29.9. Is that cool?
Yeah, that's why I don't understand how we start from 10.
Because
Is
they
that
ask
like the year?
No. What is the data in this year is sort of a data, but what's the main data point is the ad revenue.
Mm-hmm.
That's the data.
Oh, okay.
So how many data points were there between 10 and 19.9? It looks to be 1, 2. There were just 2.
Oh, okay.
And then you go to the next class and you say, yeah. Okay. So you're right. The years are there, but they're not the actual meat of the data that I want to analyze.
Okay, so we don't use those for the rest of the questions, the years.
The years, no.
Okay.
So
Okay.
if I wanted to make like a time, I could graph the points. Like I could graph, this would be, I could even say 0, 42.9. You know, I can make a scatter plot. That's not what I'm trying to do. Yeah.
Okay. So then for the 5, I would just, after I find all the classes, I would just write down which one had the most frequency.
Yeah. There you go.
Okay, thank you.
You're welcome. How's everybody else? You guys good? Any other questions? If not, I'm gonna head out. All right, guys. I'll see y'all tomorrow.
Have a good one.
I will. All right. Bye, everybody.